Howdy students, this is a video that is going to cover an equation that is used to calculate heat energy. So we're going to go through the equation and then we're going to do 4 examples, and that will be this video. So to calculate heat energy required for a temperature change, we're going to use the following formula. So here is our first equation we're going to use in the thermochemistry unit, and we have the letter Q. That's going to represent heat energy, either absorbed or released. So one thing I would write in here is that you can have a positive value, which is going to mean that you have either lost heat or gained heat. So a positive value means heat is absorbed. And if you have a negative value, that means heat has been released. So heat transfer is kind of a relative term. It depends on what system you're looking at. We have the letter M for mass, and that's going to be in grams. And then we have this brand new variable, capital C, which is the specific heat of the object. And remember, specific heat means the amount of energy needed to raise the temperature of a certain amount of an object, specific heat capacity. The units here, let's take a look at those. We have 2 different units we can use. We can have calories over grams times degrees Celsius, or we can have joules over grams times degrees Celsius. So depending on which unit we use, we can either solve for calories or we can solve for joules. And remember, we have a conversion factor that we can use to calculate calories or joules depending on what we need. And then last, we're going through a change in temperature, which is where the heat transfer is occurring. So we have this delta T, and delta, the triangle, means change. So that's a change in temperature, and this is 1 variable, not 2. It's just 1. And we're going to measure that in degrees Celsius because that's what our specific heat capacity is in these units. So we're not going to use Kelvin, and I'm going to write that in. In these examples, we're not going to be using Kelvin. We're going to complete 4 examples, and that will be this video. Each example is going to solve for a different variable. The first example says how much energy is required to heat an iron nail with a mass of 7 grams from 25 degrees Celsius until it becomes red hot at 750 degrees Celsius. So we're heating up a nail that weighs 7 grams. We want to know how much energy, which is the letter Q, we can also call it heat energy, is required for that to happen. So in the problem, I also gave you the specific heat capacity of iron, 0.46 joules per gram degree Celsius. Sometimes we'll give you a table where you can find these values. Sometimes you don't know what the metal is and you have to calculate for C. But in this case, we're giving it to you. So there's my specific heat capacity for iron. Let's go ahead and look at the temperature change. When we do a delta T, you might want to write this in, we're going to do the final temperature minus the initial or the beginning temperature. And that's going to tell us whether energy was gained or released. So if we get a positive value, we're absorbing energy. If we get a negative value, we're releasing energy. So to heat up from 25 to 750, we're going to have to absorb. So this should be a positive temperature. The final, which was 750, minus the initial, which was 25, to get a total, a change in temperature of 725. I'm going to plug in everything. My mass is 7 grams, so there's my M, C for iron, and my delta T. And when you calculate those, we're going to multiply all those together. We're going to use 2 significant digits here. We're going to round, and we're going to get 2,300 joules. And if you wanted to be specific, you could say that that's heat energy absorbed because it is a positive value. Next example has to do with glass. It says if 5,750 joules of energy are added to a 455 gram piece of glass at 24 degrees Celsius, What is the final temperature of the glass? So the specific heat of glass is given 0.50 joules per gram Celsius. I'm going to use Q equals mcAT again. But this time, we're looking for the final temperature. So I'm probably just going to go ahead and solve for the delta T, and then we'll see what we have to do to get the actual final temperature, because we do have 24 degrees, but we need to know the final temperature. So this is not delta T. I'm going to write that in. This is not delta T. This is our T initial. Specific heat of glass is given in the problem. The delta T is what I'm looking for. So I'm going to plug in Q, and it's a positive value. Heat is added, so we're absorbing 5,750 joules. My mass is 455 grams. My specific heat for glass is given in the problem, and I'm solving for delta T. When I do that, I get 25 degrees, and it's a positive value for the temperature. So if I'm adding energy, my change in temperature is going to go from a lower number to a higher number. I'm actually adding this temperature change. So I'm going to do 25 plus the 24 degrees that we started in order to get a final temperature of 49 degrees Celsius. So I'm going to summarize up here. If you add heat, the temperature increases. But if you remove heat or release heat, the temperature decreases. Third example, a 30-gram sample of an unknown metal is heated from 22 degrees to 59.2 degrees. So we are increasing in temperature, which tells me I'm adding energy to the system. During the process, 1 kilojoule of energy is absorbed by the metal. What is the specific heat of the metal? So I've got a mass. I've got a delta T here that I'm going to have to calculate. I do have a Q in energy, and you'll notice that it's in kilojoules. I may have to convert. What is the specific heat? So I'm looking for this unknown metal. So the equation is Q equals mcAT. They've rearranged it here to solve for the letter C. The delta T, we're going to do the temperature final minus the temperature initial. And again, that's going to be a positive value for the temperature. We're increasing in heat, which will give us a positive energy. So when we plug in 1,000 joules, so I'm going to show that up here, 1.00 kilojoules, we need joules. So for every 1 kilojoule, there's 1,000 regular joules. And that's what I plugged in down here. My mass is 30 grams. My delta T, I had to calculate, is 37.2. When I solve, I get 0.896 joules per gram degree Celsius. Now, I could take this and I could actually look it up in a chart. And what I might find is an element, some sort of alloy. We know it's a metal. And I can actually identify. So we may ask you to do that on a certain question there. And the last example, we're going to be solving for the mass, since that's the only variable we have not solved for. If it takes 3,590 calories to heat up a sample of water by 12.2 degrees, what is the mass of the water? I'm going to need the specific heat of water in order to solve this. I have my letter Q. I have a delta T. It says the water changes by 12.2 degrees Celsius. What is the mass of the water? So back in our notes, the specific heat of liquid water was either 4.18 joules per gram Celsius or 1.00 calories per gram Celsius. So we took that from our notes. This is the letter Q. This is our specific heat for H2O. And our delta T is a positive 12.2, which means we're increasing absorbing energy. And when we solve, we get the mass of the water as 294 grams.